Okay, and whatever will be the length of this total path you have covered will be the distance between your home and school, right? And here I have mentioned a word that is irrespective of its direction. So when you started, you were directing towards your school. Say this total distance was say 3 kilometers. Okay, if this is 3 kilometers and you went to your school and your school is now done, you have finished with your school. Now you are coming to your home. Now your direction has changed. First you are heading from your home to your school, and now you are heading from your school to home. Now it is in completely opposite direction. So does the distance between the school and your home will start reducing, which was 3 kilometers? Now will it go on decreasing like to 1 and then 0? No, it never happens, right? So first we started from home, then went to school. It was 3 kilometer, and when you will start from your school and then come to your home, it will again be 3 kilometers. So total distance traveled from your home to school and then from school to home will be 3 plus 3, that is 6 kilometers. 3 plus 3, that will be equals to 6 kilometers, and because of which this, irrespective of its direction, plays an important role whenever we are discussing the distance between any two objects. So as the distance is not taken into the consideration, this quantity, which is the distance, becomes a scalar quantity, means it only has its magnitude. Means it will only have a magnitude and there will be no direction. And to measure the distance, we use its standard unit as meters. Okay, so to measure the distance between any two points, we use the odometer. This is a very important meter which is given in every vehicle. The instrument used to measure the distance is odometer. Okay, so now we'll move on to the next part of our topic, which is the speed. So speed is in how much time a object changes its position, means how fast it is, how slow it is. We measure it using the word speed. How fast or slow an object moves is given using its speed. So as it is mentioned here, the time rate change of position, the time rate change of position of the object in any direction. In any direction. Here also we are not taking the direction into consideration. Even if we move from left to right or from right to left, the speed will always keep on increasing. It will never decrease, even if we are moving from left to right or right to left. And to calculate the speed of any object, we have a formula given over here, that is speed equals to distance traveled upon time taken. If we take an example of, say, you are going to any village, say, which is 120 kilometers away from your home, and it takes 3 hours of time to reach to your village. So how you will calculate the speed? So as the formula is given here, the distance traveled. So how much distance you are supposed to travel? It is 120 kilometers. So you are supposed to travel 120 kilometers. And how much time does it takes? It takes you 3 hours. So 120 upon 3, how much it is? It equals to 40. So your speed will be 40 kilometers per hour. Okay, so in this way, we use the formula of speed to calculate the total speed of the object. So as there is no direction of the object considered in this concept of speed, it is again a scalar quantity, right? And to measure the speed, we have a standard unit, which is a SI unit is meters per second, and it is represented using this meters per second. Okay. So now, as we have discussed speed, there are different types of speed which we'll be discussing now. So the first is uniform speed. So uniform speed is when an object covers equal distances in equal intervals of time. Okay. Say an object starts its journey from this point A and goes till point B. This is point B and this is point A. Say its path is this way. And we break this part into three different intervals. So this is 1 kilometer. So this is 1 kilometer, and this is again 1 kilometer. So to travel this 1 kilometer, the object takes 1 minute of time. Okay. And here also to travel this 1 kilometer, the object takes 1 minute of time, and the again third interval also takes 1 minute of time. So now you can see the distances. This distance, all distances are equal. This is 1 kilometer. This again is 1 kilometer, and this again is 1 kilometer. So we have break down our total journey into three different parts, and these all three parts are equal, and the time taken to cover this distance are also same. It is 1 minute, 1 minute, and again here 1 minute. So whenever we'll see such type of motion in which the equal distances are traveled in equal intervals of time, we will call the such type of speed as uniform speed, where an object covers equal distances in equal intervals of time. Okay. So now what if the in equal intervals of time and unequal distances are covered? What will happen? So in that case, we'll call it as non-uniform speed. Consider we start from point A and we go to say point point B. So say we have made three different intervals. Say this is again 1 minute, 1 minute, and 1 minute. Here we have made equal intervals of time. But now what happens? You are going from say point A to B and you are on a cycle. Okay. Consider you are on a cycle. So from point A to this point, what is there? There is a steep slope, like एक चढ़ाई है वहां पर ऐसे ऊपर. So whenever we try to ride our bicycle on this type of slope and you're coming from this point, what happens? You need more time to travel this distance, right? So say we'll say that you will travel only 500 meters over here, or say 0.5 kilometers you have traveled over here. And now once you went up the hill of the slope, there is now say this type of slope now from which you will move down. Okay. So in this 1 minute, next 1 minute, you traveled 1.5 kilometers now. You have traveled now 1.5 kilometers. And this last 1 minute is again a straight road. So on straight road, you covered say 1 kilometer. So in equal intervals, that was 1 minute here, again 1 minute over here, and again a 1 minute over here. We covered different unequal distances. First it was 0.5 kilometers, it was 1.5 kilometer, and again a 1.5 kilometer. So in this case, in equal intervals of time, we covered unequal distances, and such type of motion where unequal distances are covered in equal intervals of time, we called it as non-uniform speed. Okay, so now we'll move on to our next type of speed, that is average speed. Now we'll study about the average speed. Average speed is the ratio of the total distance covered by the object to the total time taken. See, there is a formula given over here that average speed equals to total distance traveled upon total time taken. Say, you are going from your house to your village. You are going to your village, which is 60 kilometer away. What you do is first in your first 20 kilometers, you travel very fast and you cover this 20 kilometers in say 20 minutes. You cover this distance of 20 kilometers in 20 minutes, and the next 40 kilometers and the next 40 kilometers you cover it in say you took 70 minutes. So the total distance traveled was 60 kilometers. 60 It was 60 kilometers, and the total time taken, which is 20 minutes plus 70 minutes, total time taken is 90 minutes, and 90 minutes is equals to 1.5 hour, 1.5 hours. So our total distance traveled was 60 kilometers. So to calculate the average speed, we'll take 60 in our numerator, and the total time taken, this total time taken is 1.5 hour, that is 1.5. And when we'll divide 60 by 1.5, we'll get answer as 40, and our speed, that is the average speed, comes out to be 40 kilometers per hour. Okay, so in this way we calculate the average speed of any object. Okay, so now we'll move on to our next topic, which is displacement. Till now we have considered the distance in which the direction was not taken into consideration, right? In whichever direction we went, our distance was always increasing. But in this case, when we'll be discussing about the displacement, we'll consider the direction also. So now see how the direction is taken into consideration. So displacement is when a body moves from one position to another. The shortest distance, see the shortest distance, that is the straight line between the initial position and the final position of the body along the direction. Now see here the word direction is used, along the direction. Along the direction is known as displacement, and as we see that the direction is taken into consideration, we will say that displacement is a vector quantity, and to measure the displacement we use its standard unit as meters. Now see what is the difference between the distance and the displacement of any object. See, say if we start from point A, this point A, and we are supposed to go to the point B. See, and the path covered is this, the red dotted line. We are going through this path in this way. So our distance will be the length of the total path covered. So our path covered was this, the red line which I have highlighted with my black marker, and there is also distance written over here. So this was our distance. But what about the displacement? The displacement is a, see, as you can see in the definition, it is a straight lines between the initial position and the final position of the body. We started from this point A, which was our initial position, and point B is our final position. So to represent the displacement, we'll draw a straight line between A and B, and this will be our displacement. And to calculate the displacement, we'll always need the direction, like in which direction our final point is, or the final position of the body is. Say if not B was not our final position, and say C was our final position over here. So our direction, in which direction the C is from A, will be the main concern. So we always draw the straight line in the direction of the C. Okay, and this line will be our displacement. Okay, this line will be our line of displacement. Okay, and for distance there is no need of direction. We only need the length of the total path covered. Okay, I hope I am clear till now. Now see, there are some points related to displacement. So the displacement of an object in motion can become zero with time. But the distance will become zero? No, the distance never becomes zero. The distance always keep on increasing. As I mentioned before that to measure the distance we use odometer. सबके गाड़ी में जो मीटर लगा होता है उसे हम ओडोमीटर कहते हैं. So have you ever seen that the reading in the odometer has started reducing? No, it never reduces. It always keeps on increasing. But what about the displacement? Displacement can become zero with time. So see how the displacement can become zero. Say you started your journey from point A, you went out to point B over here, and you are done with the work which you are supposed to do at the point B, and now you start your journey again back to point A, and you again start your journey from point B to point A, and you are now, your final position is equals to your initial position. Now you are again on the same position, right? So as you came to the same position again, there is no change in the displacement, right? आपके और आपके फाइनल पोजीशन के बीच में कोई अभी डिस्टेंस है ही नहीं, कुछ अंतर है ही नहीं. सो इन दिस केस आवर डिस्प्लेसमेंट बिकम्स zero, and it will take some time, right, to move from A to B and then again move from B to A. It will take some time, right? So displacement can become zero with time, but the distance covered by any object in motion can never become zero with time. It always keeps on increasing. So अभी distance जो है, और distance from between A to B and B to A, it will never become zero. Distance will never become zero. Our displacement can become zero, but distance will never become zero. See, these 2 points are very important. Make sure that you write this in your copy. Okay. And there is one more point given over here, that the ratio of displacement and distance is always less than or equal to 1. This is again a very important point. Okay. The ratio of displacement with respect to distance is always less than or equal to 1. Means what? Our displacement is never greater than or equal to the distance. Our displacement will always be less than or equal to distance. मतलब इसका मतलब क्या, डिस्प्लेसमेंट जो है वो डिस्टेंस से कम हो सकता है या उसके बराबर हो सकता है. सो इफ से वी स्टार्ट फ्रॉम दिस पॉइंट A and go to point B in a straight line. We went from point A to point B in straight line. So in this case, our distance is equals to our displacement. Our distance is equals to our displacement. Our distance is equals to our displacement. But what if we move from point A to B in this way? Now our distance is more than our displacement. Okay. So for this purpose, our distance can be equal to displacement, but displacement will never be greater than our distance. So for that purpose, we use this identity. Okay. Or we can also take the inverse and say the ratio of distance and displacement is always greater than 1. Okay. And see, there is one more important line given over here. It says that we can also say that the displacement is always less than or equal to distance. See this. This is again a very important point. Make sure that you write this in your copy. And distance is always greater than or equal to the displacement. Now we discuss about the displacement. Now we'll discuss about the velocity. Velocity is the rate of change of displacement of a body. The rate of change of displacement of a body means how fast a body is displacing itself or how slow a body is displacing itself. It is expressed using the term velocity. And as we saw that the displacement, in displacement we were taking into consideration the direction was taken into consideration as we were calculating the shortest distance between the final point and the initial point, and it was always a straight line. So to calculate the velocity, we need displacement, and as displacement is a vector quantity, our velocity is also a vector quantity, as the magnitude as well as the direction is taken into consideration. And to measure the velocity, we use its standard unit as meters per second. Okay, its SI unit is meters per second. See, if we take an example, if we start our journey from point A and point B, and we take 1 minute to move from this point A to point B, but the distance is obviously more. You can see that the distance is this red line. It has a more length as compared to this displacement, right? This displacement is shorter than the distance. Say this distance is say it is 100 meters, but this displacement was just 70 meters. So in this case, our speed will be 100 meters, which was a total distance. For speed we use distance, and for velocity we need displacement. So in this case, our speed will be 100 meters because 100 meters was our distance, and upon this 1 minute, our time taken was 1 minute. So in this case, our speed will be equals to 100 meters per 1 minute. Okay, but what about now velocity? To calculate velocity, we'll need displacement. Our displacement is how much? 70 centimeters, 70 meters. And to cover this 70 meters, we need only 1 minute. So our velocity will be 70 upon 1 meters per minute. Okay. So now our velocity of an object can be positive, negative, and zero as well. Now see how it can be positive or negative. Say if we consider this point 0 as our origin or the initial position, and we first went on in this direction. So this direction will be considered as the positive direction, and later we decided to go on in this direction. But these two directions are completely opposite to each other, right? And when we move in completely opposite direction, so we call it as a negative direction. And as the displacement needs magnitude as well as velocity, magnitude as well as its direction, so our velocity also requires magnitude as well as its direction. And as direction is changing completely opposite, so will be our sign. First it was positive and later it has become negative as it has changed its direction in completely opposite way. And say we went on to this point A and then went on to point B and again came back to the same point O over here. So our total displacement was zero even if we require some time. So as we know that velocity is displacement upon time. Our total displacement was zero because our final position is equals to the initial position. So as this displacement is zero and we say took 10 minutes to cover this displacement or to do all this journey. So we know that 0 upon anything is equals to 0. So in this case, our velocity can also become 0. See, I mentioned over there that it can be positive, negative, and 0 as well. So our velocity depends on the direction. And depending upon the direction, we will say that our velocity is positive, negative, or 0. Okay, so velocity, moving on to next point, that is velocity of an object can be changed by changing its speed or the direction of the motion. So see, if we are traveling in straight line, for example, we were traveling in straight line. What we do is we change its speed. Whenever we are traveling in straight line and the speed is changing, so in that case, our velocity will also change. Okay, so when we are traveling in straight line, if our speed changes, see there is mention of speed. If we change our speed while traveling in straight direction, our velocity will also change. But even if we keep our speed constant and say we were first going straight and after going straight we change our direction. Now we started going in this direction. We started moving in this direction. So in this case, as the direction is changed, our velocity will also change because as we can see over here, the velocity of an object can be changed by changing its speed or the direction of the motion. Now we have changed the direction. In this case, we have changed the direction, and as the direction has changed, the velocity will also change. Now, moving on to the next point, for any object in a time interval, the modulus of velocity means the magnitude of the velocity is always less than or equal to the speed. मतलब क्या, जो हमारी velocity है, velocity will always be less than our speed. It can be equal or it can be less than. Velocity will always be less than or equal to our speed. And we also know a similar relation between the displacement. Or displacement is also less than or equal to our distance. So these 2 points are very important. Make sure you write these points in your notebook. Okay. So now we'll be discussing about the different types of velocities, in which the first is uniform velocity. In this, it is same as that of uniform speed. When an object covers equal displacements in equal intervals of time, it is called as uniform velocity or constant velocity. Okay. So when an object covers equal displacements in equal interval of time, it is called as uniform velocity or constant velocity. It is same as that of speed, in which we saw that we having a journey from point A to B, and in which we break our journey into three different parts of 1 minutes and 1 kilometers, and equal distances were covered in equal intervals of time. Same is the displacement. If an object covers equal displacements in equal intervals of time, it will be called as uniform velocity. And next is non-uniform velocity, in which an object covers equal displacements in unequal intervals of time. You will never say that unequal. It will never happen. Both will never be unequal. Okay. दोनों भी एक साथ unequal कभी नहीं होंगे. Either displacement will be equal displacements in unequal intervals of time, or unequal displacements in equal intervals of time. We'll never use unequal in both the cases, like unequal displacements in unequal intervals of time. For example, say this is our total journey and we break it into two parts. In the first 1 minute, we covered 1 kilometer. We covered 1 kilometer, and in the next half of the 2 minutes, we covered 2 kilometers. So now our displacements are also unequal and our intervals of time are also unequal. But if you look minutely and I break this 2 minutes time interval into again two parts, I can say that it traveled 1 kilometer in 1 minute over here, and again in 1 minute it traveled the same 1 kilometer. So this is now again equal intervals and equal intervals of time, and this is again going equal to our uniform velocity. So whenever we mention about non-uniform velocity, unequal will be used for only one thing. Either it will be for displacements or intervals of time. I hope till this everything is clear. So now our next topic is acceleration. So in this, it is the time rate of change of velocity. Like we saw uniform velocity was when equal distances in unequal intervals of time. And to measure this change, like how fast the velocity is changing or how slow the velocity is changing, we use one term that is called as our acceleration. And as we are dealing with the velocity, we saw that velocity was again a vector quantity. So our acceleration will also be a vector quantity, and its SI unit is meters per second square, where this is not a right, is meters per second square. Okay, so to measure the acceleration, we have a standard unit as meters per second square. And we have a formula to calculate the acceleration as the final velocity upon initial velocity upon the total time taken. It is also given as final velocity as v minus our initial velocity, that is u, and upon total time taken, that is t. If we consider an example of, say, our initial velocity, was 2 meters per second, and our final velocity is, say, it becomes 8 meters per second, and our total time taken was 3 seconds. So in this case, our acceleration, what is the formula for acceleration? Our acceleration is equals to final velocity minus initial velocity. Our final velocity was 8 meters per second. So 8 minus our initial was 2 meters per second. So we'll subtract this 2 from 8. And what was the total time taken? The total time taken was 3 seconds.